Hello, scholars. All right, first review on derivatives. Like we did yesterday, derivative just means slope of the tangent line. So if I'm looking at this picture, let's say this part of the graph, it's increasing, so the derivative is positive. Okay, now the tippy top part of the graph, the derivative is 0. So if you have any max or min, the derivative is 0. Max, min, critical points in other words. If you continue this work, right here it's decreasing, so the derivative has to be negative. Right here is also decreasing, so our derivative is negative. Okay, let's choose a different point. Maybe up here would be 0 again. Maybe over here it's positive. Maybe all the way at the bottom is another 0. Okay, so that's how you determine the derivative based on the graph of a function. We already know that if a function is differentiable, meaning it has a derivative, then the function has to be continuous, meaning no problems. Okay? No holes, no jumps, no asymptotes. Another thing that we're going to see in this review is instantaneous rate of change versus average rate of change. Average rate of change means slope, like in algebra, okay, which is y2 minus y1 over x2 minus x1. Instantaneous rate of change means derivative, so we actually have to use rules of derivatives. In terms of limit definitions, we're going to see some problems that they try to confuse you because they give you a problem in this format, but really what they're asking is to solve for the derivative. We're going to go through that. Now I need you guys to go to your Barron's book, page 115, because all the rules of derivative are in there. I didn't write it on the sheet. It's in your Barron's book, page 115. Please go to this page. Please review the rules, especially if you have forgotten them. Okay, a few of the rules that will stick out to us. The power rule. This is our favorite one. This is, let's say, when we have 16x to the third. This is when we circle the exponent, multiply it down, subtract 1. Okay, so this is the power rule. The product rule is a little bit long. This is when functions are being multiplied. Okay, so let's say we have x to the third times sine x. This is when we have to split it up, where there's an f and a g. Then we have to do f prime, which is 3x squared, and g prime, which is cosine of x. Then we have to put it together using f prime g plus f g prime, where we just follow our setup. So f prime is 3x squared, g is sine x, plus f is x to the third, times g prime, which is cosine of x. So this is a little bit long. Product rule. Next thing, we have the quotient rule. So very similar to the product rule, it's a long formula, but we use it when two functions are being divided. And I'm just going to write it on the side here. It's going to be low d high minus high d low, or all over low squared. So I'm not going to write down an example for that. We're going to go over it in the examples. Okay, chain rule, this is going to be used a lot. Okay, so a quick example. Let's say we have x squared plus 2 to the third power. Okay, so we just treat it like normal, circle the exponent, bring it down, subtract 1, so I have 3 x squared plus 2 to the second power. But then we have to times it with the derivative of what's inside the parentheses. The derivative of x squared plus 2 is 2x. So this whole thing is the answer. This whole thing is the derivative. Other rules, our favorite one, derivative of e to the x is e to the x. Wonderful. Derivative of natural log of x is 1 over x. Okay, so I just wanted to note here, which we're going to apply a lot later. You can take the derivative of a piecewise function, just take the derivative of each piece, meaning if I have f of x equals x squared and like let's say 3x plus 2, and then this is x bigger than 5 or x smaller than or equal to 5. If you want to get the derivative of this, just take the derivative of each piece, okay? Derivative of x squared is 2x. Derivative of 3x plus 2 is 3, and just copy the domain. I'm going to do some examples with that later. Do not fret. Okay, another one that we never use, ever, 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 is a to the x. So that just means if I have, let's say, 3 to the x, the derivative of 3 to the x is going to be 3 to the x times natural log of 3. We barely use it, but it is something that might show up, so we have to remember. Another thing is PVA, however way you want to remember it. And moving to the right, you have to do the derivative of each to get to the next one. Okay, if we see the word speed, that just means take the absolute value of velocity. That's all it means. Okay, if you just see the words slope of the curve, derivative, rate of change, derivative, they all mean the same thing. If you see the word slope at a point, it still means derivative. It still means slope of the graph. It means the same as slope of the tangent line. You get it. If you see the word slope, 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 rate of change, they all mean the same thing. They mean derivative. Okay, so this is just the first review. We're going to have about 3 days in total of reviewing all the examples in the AP that uses derivative. So we're going to break it down. You can start the first set today. So go to the next video, please.